Particle having mass and charge of, so charge is positive. So we have a positive charge. Okay. And the particle is given an initial horizontal velocity. So horizontal velocity is given, and that horizontal velocity is v, and some magnitude is there. Now, in the presence of electric field E and magnetic field B, okay, now to keep it moving in the horizontal direction only, okay, so there's going to be no change in the direction. And which of the following pair of statements is possible? So we have to see the possibilities. First, B should be perpendicular to the direction of velocity. Okay, so B can be in any direction which is perpendicular to the velocity. Okay, fine. And E should be along the direction of velocity. Okay, E is in the direction of velocity. So now you see, when B is perpendicular to the direction of velocity, so B can be in YZ plane, in any direction, YZ plane. Okay. Now V is in I cap. Okay. So if you see, like if it is in YZ plane, so if I write B Y J cap plus B Z K cap, okay, and QV cross B, V I cap cross this. So I cross J is going to give us K, and I cross K is going to give us J or minus J point, it's perpendicular. So now the force is either in K direction or in J direction. So the force is perpendicular to this, to the force which is QE. So there are two forces which are going to act. One is QE, which is in I direction due to the electric field, and due to the magnetic field, the force is going to act in either K, J, or a combination of K and J. So again, the point is that now there is an extra force which is perpendicular to the direction of velocity, and therefore the direction will change. Okay, because again I repeat, it's QV cross B. So V cross B is going to be in a plane which is perpendicular to both V and B. So when it is perpendicular to V, that means it is perpendicular to Q into E also. Okay, because electric field and velocity, they are in same direction. So therefore one cannot be. Okay, because cannot be the answer, because we are getting a plane, we are getting a force in a perpendicular plane which is perpendicular to the velocity. Now both B and E should be along the direction of velocity. Let us discuss about this. So B is also in this direction, E is also in this direction. Okay, and velocity is also in this direction. So B will have the force QV cross B. So magnetic field force is going to be 0, and this electric field will apply force in this direction. So since velocity is in the same direction as that of acceleration, so therefore it will continue to move in a straight line. So second can be an option, first is discarded. Third, both B and E are mutually perpendicular and perpendicular to the direction of velocity. This may work, because if you see, if I keep, let us say, this is the velocity direction, and I keep B as into the plane of the paper, so QV cross B above, so the magnetic field will be in this direction. Now if I put electric field in this direction, so then the QE, which is force due to electric field, will also be in the below direction. So now both can cancel each other. See, they're asking, is it possible? Yes, in this case it is possible if qv cross b is going to be equal to qe. Okay, because both the forces, magnetic and electric, they are in opposite directions. So therefore third will work. Fourth, b should be along the direction of velocity and e should be perpendicular to the direction of velocity. The fourth part. So this is the velocity v direction. Now b, magnetic field, is along the direction of velocity. Okay, and e is perpendicular. So force due to magnetic field is going to be 0 because angle is 0, and the electric field is in this direction. So therefore qe, which is force of electric field, is perpendicular. Since acceleration is perpendicular to the direction of velocity, there is going to be a change in direction. So therefore fourth option will also not work. So only option which is going to work is 2 and 3. So therefore C is going to be the answer.